I'm John Wilker, the organizer of 360 IDEP. I hope you enjoy this session recording, but first I wanted to mention one thing. We've served the community since 2009, and over the past few years we've had to take on debt in an effort to keep the conference alive. After several unforeseen challenges, not the least of which is a pandemic of indefinite duration, we've had to make the hard choice to end the conference as we're now facing over $100,000 in debt. As a result of requests from the community of how they can help, we've created a GoFundMe campaign. If you're inclined and able, please consider donating to help keep 360 IDEP going. The QR code after this will link you to the campaign. Thank you. Enjoy the recording.
All right, so we can get started. So basically, I'm going to talk today about SwiftUI performance for demanding apps. And there are two main reasons why I'm doing this talk. The first one is basically, I've seen a lot of blog posts and explanations and examples all over the internet about how to do things in SwiftUI, how to achieve some tab bar or some situation in your UI. Most of them don't talk about how to do it with performance in mind. And then the second reason is that I feel like a lot of the misconceptions or challenges that people have with SwiftUI are due to not fully realizing the philosophy behind SwiftUI, or maybe kind of expecting it to work a little bit like UIKit used to be, sort of like as a nicer API for UIKit, and not something that's completely different. So we're going to start with the philosophy, actually, and how SwiftUI works under the hood, and then we're going to see how to use that in the second half for a few specific things you can do to improve the performance. So the first thing is a quote from Luca in a WWDC talk in 19, which might be the most important single sentence TLDR about SwiftUI philosophy, which is views are essentially a function of state. And I'm going to kind of like chew on that sentence for a while during this talk. And so here is Luca himself saying that. Let's see if this is going to work. Function of state. Okay, it was a little bit quiet. So here's Luca again saying the exact same thing.
View are a function of state.
So that's a very nice, dramatic sentence. The question is, what does that even mean? We're not mathematicians. We want to build apps. And more importantly, how can this help us write UI code quickly? Because in the end, we can all do UI with UIKit or AppKit. SwiftUI big guarantees that you don't need to work as much. So how does that dramatic sentence help us? So to understand that, we kind of need to change our mind a little bit into this new science of writing UI, or writing UI in this new way. And I kind of, it's sort of like a journey for our brain in some way. And I call it the journey from imperative thinking to declarative thinking. The problem is that this journey is not very easy. And it has a lot of challenges, like I said in the beginning. So let's take a step back, from SwiftUI. Let's start with something we all know. And again, I'm going to focus on UIKit because that's what I know best before SwiftUI. But I assume it applies to AppKit. If not, I'm sorry, all the Mac people. So with UIKit, essentially what we have is we have the view controller and the view. You can kind of see them as king and queen of the situation of your UI structure. They are long-lived, which is one of the most important things here. And then they own their state, they keep their state, and then they either have delegates to do event passing, or they just do event passing themselves. View controller might pass an event to a view, or within itself, or from one view to another view, but they handle that situation. So if we outline how UIKit is working in a nutshell, your view controller coordinates everything. It's long-lived, which means references are kept. You can keep a reference of view or view controller performance, for navigation, for whatever you want. Views and view controllers own their state. They know their size, and they are the ones doing event passing. And then SwiftUI comes, and it's this cool new hotness. And it's completely different. Like, nothing is even similar in any way. First of all, the king is now the state, not the view. View controllers are nowhere on the slide even. Delegates are not here, they don't exist. And even the views, if you see, they're kind of like, it's kind of like, do they even exist? What are they even? They come and go, what's going on here? It's mostly the state is the whole situation here. So if you compare it to UIKit, first of all, view control doesn't even exist, like you all know. The views are very short-lived. The OS will recreate them as many times as it wants, and it's going to be many, many times, probably more than you expect, which means references don't even make sense. Even if views in SwiftUI were a class, technically it wouldn't make sense to keep a reference to a view. They don't own their state, which is very important to understand. Yes, even at state, they don't own that. And they don't know their size, they control their size, which basically, actually something we're not going to talk about today. It's about the layout system, but it's also important to know. And then there are usually no events, just mutations. And so that's a lot of differences for a new system that's supposed to do basically the same thing. And so the big question is, why? And the main answer is that keeping your state and your views in sync is not an easy task. It's so hard that it's probably one of the biggest challenges in writing GUI since GUIs exist in like the 1500s or whatever. So there are a few examples we know about. For example, rotating the device. We have it easy in iOS, but Android solution to this problem is killing the entire screen and rebuilding the screen from scratch completely because keeping view and state is so hard. Updating previous views on navigation stacks. I'm sure you all had this bug where something changed on some view controller in the front on a stack, and then you need to keep that in sync with the view controller in the back of the stack. You hit back, the thing doesn't update, you need to keep all that in sync. It's all very hard. And just in general, trying to make sure that when you do something, it doesn't also affect something else by accident, because you try to kind of keep track of all the events and all the states and all the things that needs to be in sync. And then obviously something that you didn't expect suddenly happens. So what we can do about it. So like I said with Android, this is one solution. You can literally shut it down and restart. And that's the classic solution of, I don't know, kernel panic and the blue screen on Windows and a lot of other situations where you just kill everything and start with a fresh view, fresh state, and fresh everything. And then SwiftUI basically is trying to not do that. And that is using the declarative approach. And the declarative approach basically has, or the way I see it at least, this is not like an official definition. The way I see it is that in the declarative approach, I just realized I can see the same slide here. So everything only changes the state, and that means you will never change the view. You will only change the state. And then nobody exclusively owns that view, so you will never keep the text that the label is showing, for example. You will only keep the state that will cause your view to change, and then your view decides, do I care about the state, do I not? I'm going to change, am I not going to change? So how does that look? So I'm going to go back to the sentence we saw from Luca in the beginning. A nice way to think about that is that let's imagine that view is actually a function of state. Let's imagine that this is the API of SwiftUI. We get some state, some identifiable, and we return something. And this is obviously not actual. This is not real. But this is actually, in my mind, this is a good mental model for thinking about what actually is a view in SwiftUI. You can kind of think about it this way. All you do is you get some state and you return something. You're not supposed to do anything else beyond that. And so let's say we have this graph, this view tree, all the orange ones are views, and then the purple ones are the states that are associated with the views. And let's say we have some state change. New dependency, new state, whatever, something happened, and we now need to make a change. So what happens in SwiftUI is that the first thing that the framework will do is first of all, it will create a new view, which is basically taking just the state and the dependencies of the view that depends on those dependencies and compare them with the existing state that's currently on screen. If at that point they are equal, SwiftUI will basically throw the new state out the window on the floor, and we're done. We're not going to get a re-render. We're not going to get anything happens beyond that. Only if they're not equal, then SwiftUI will be like, OK, I need to check the body. The body is the actual content. This is actually what's on the screen. And only then SwiftUI will give that state to your view's body property and ask your view, can you please tell me what you're going to show from that state? This is again evaluated and again compared. And if the bodies are the same, we still don't do anything. Thrown on the floor, we keep what's current on the screen. And only if they are not equal, only then we take the new body, we render it to screen. That's what's called the render phase. And then we get rid of what we currently have on the screen. So a more accurate analogy to the analogy I had a second ago, it's kind of like we have view is sort of two functions of state. One is what are your state and dependencies, what you care on, or what you depend on, and what you care about. And then the second thing is what's your body based on some state. And they should probably match each other. And then you see that and you might think to yourself, okay, where does business logic go? And the answer is to nowhere. So in UIKit, again, with view controllers, which is naturally where most of business logic used to go, we used to have two kinds of logic. The first one was passing events, like you saw earlier, and changes between views. And the other one was handling and serving data, which is also called CRUD. And then in SwiftUI, the first one is basically redundant because we only change state. And the second one, it's kind of, if you used view controllers correctly, that should have never been in your view controller in the first place, for the most part. And so what that means is that SwiftUI basically has no use for view controllers anymore. The first one is taken care of for you and is redundant, and the second one, you should just put somewhere else. And so basically now, the framework is telling you to do it the right way, or at least the way Apple imagines it, that it needs to happen. And so this is made-up example of some made-up app that doesn't exist, structure. And you can see I might have different things. I might have network and caching and core data and blah, 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 and a bunch of other stuff. And then all that will affect the state, which is my navigation router, my current user, my feed provider, and the SwiftUI views only depend on those. SwiftUI does not care about anything that happens beyond that level. And it doesn't change any of that, and it doesn't affect any of that. So this is all very, this is just a random example. Answering how to do this right is not easy and beyond the scope of this talk. I'm going to focus on the yellow part that you see at the bottom. And specifically, I'm going to focus on what happens when the line in the middle changes a lot, and that affects your views to change a lot, but you want to keep your app performance with 60 frames per second, 120 in the new iPhones, and make everything fluid. And so basically, we want to focus on performance today. And so performance on SwiftUI, at least, I kind of see it broken down into three sections, or three things that can affect performance. The first one is less diffing, which is what you saw earlier, making your views, or making SwiftUI need to diff between your views and your state less times. And the second thing is fast diffing, which means when it does already needs to diff your views and your states, make sure that it happens as quickly as possible. And then the third is expected behavior, which is something between performance and behavior, but many times on SwiftUI, we end up doing things that don't have the behavior we expect. So that's kind of also affecting the performance of our app. And so I'm going to have these 3 tags, and this is sort of moving us to the second part of our talk. Let's see how much time. Okay. So this is moving us to the second part of our talk, which is specific things that can either make your SwiftUI code have less diffing, have faster diffing, or have the expected behavior. So let's get started. So the first one, keep view body simple. And I'm going to go from the more obvious things slowly to the more esoteric things. And so we're going to start with something that's supposed to be very clear. I think also Apple talks about it a lot. On the left, you see something that might happen in your body property, which is you might do some I/O to get whatever, some items. You might iterate on those items, and then you might do some complicated sorting on those items. And then finally, you have the items you want to show in your for each list, whatever, and you create the content. So this is a problematic because your body is getting called so many times you don't even know. Your body might be called multiple times in a single layout phase. That means that your state changed once, but SwiftUI needs to call the same body of the same view 3 times for whatever optimization reasons of the framework. So you need to assume that your body needs to be as simple and as fast as possible, and that essentially means do nothing. That essentially means take the state, present it. If I need to do something with that state, if I need to sort it, if I need to do some I/O, some cache, something, do it somewhere else async. And this is kind of like showing what I showed earlier in code. I might have some cupcakes, some cupcake view, and I don't want to show the cupcakes as is. I want to sort them, I don't know, based on how delicious they are, for example. So an easy way to do it is to just sort them on the fly inside body. Then I know that I don't have any race conditions. I know that, whatever is the latest cupcakes I have, those are the ones I'm going to show. This is pretty bad because this is, you're essentially changing the state and you are doing this heavy computation inside your body. And so something you can do instead is you can have this cupcakes provider, and that thing is what holds your state, your cupcakes, and it provides the cupcake somehow. It affects the state, basically. And so it will fetch the items from wherever. It can be I/O, it can be network, it doesn't matter, or core data. It will sort the items, again, that complicated sort, and only then it will set the cupcakes. And then, for those of you who don't know, the thing about published is that your view doesn't care what happens with that provider until one of the published properties change. So only when you do self.cupcakes equals sorted items, only then your view will sort of wake up from object did change and say, oh, I have new items, I need to show them. At that point, they're already sorted. And so if we take the same cupcake view, it's pretty simple. Instead of holding items, now we hold that provider. Sorry, I said hold, that's not technically true. We subscribe to that provider, to that state. And that provider is what has the items and what's doing the complicated computation for us. And then we can say something like showing the cupcakes and then open a task, on a peer is also very good. There is very little difference, by the way, between on a peer and task. As far as I know, the only technical difference is that dot task is already async and is canceled for you when the view disappears. So that's basically the main benefit of task over on a peer. If you use iOS 14 and you cannot use that task, you can do the same thing. Inside on a peer, you can just create a task, do that. Inside on disappear, you can cancel your task. Yes?
Is there a reason that the provider is a very noticeable object as a state rather than a search object?
Typo. Yes, sorry. This is a state object, not a state. This would also not compile because, this literally says class cupcakes provider. And so inside cupcake view, it needs to be a state object, not state. I think the next item is about state object, observable object, and all that. So I will go in a little bit more into that. But yes, this needs to be state object, not state. If you try to type this, it won't compile. Oh, here we go. Okay. So the next one is, this is just, I'm going to talk a little bit about state object and observed object. This is just a specific mistake that I keep seeing in code bases all the time. So that's why kind of like the TLDR of this is in the title. If you own the data, and again, own is a confusing word because I just said earlier that views don't own their state. So I know I'm a little bit conflicting myself, but you can imagine own as you are the view that creates that data or that state. So if you create that, it's a state object. If it gets passed to you, it's observed object. And you should probably just use state structs when it makes sense, because state object has all the overhead of classes and all that. But sometimes you do need a class, and there's no other choice. And then when you do need a class, this is kind of a way to so start with the code. A good way to imagine that, or to remember that, is that if you have equals something, if you provide the initializer for that item, that's a state object. If you do not, if somebody else gives you the value, that's an observed object. And then I'll go to the graph here at the bottom and kind of explain what happens. So with the state object, basically what you tell SwiftUI is you tell the framework, hey, I know how to create this. This is the default value. And by the way, that equals data provider. That's an auto closure. So you tell SwiftUI, if you don't have a value for this, this is how you create it. But if you already have a value, give me that value again. And so you tell SwiftUI, whenever you create this view, I want to get this state, whatever it was in the previous iteration of that view. And if you have nothing, this is default value. So that's the orange box you see at the corner. It's basically telling you, SwiftUI is keeping that state for you, not you. You do not return it. And then the next time, and you provide the default value, you can see in the middle. The next time you have a new version of that view, SwiftUI will give you the already existing state object that you created in the previous time. With observed object, you don't have any of that. You tell SwiftUI, I don't need you to retain anything. I don't need you to keep anything for me. Someone else, some parent view is going to give me that state object that they own, they create, they take care of. And so the very bad, not good thing that people sometimes do that I keep seeing is this. And there's a huge X next to it. Be careful, do not accidentally copy that. People would accidentally, personally, I don't even know why this compiles. I think this should not compile. You would declare an observed object, maybe by accident, like a typo I just had, or because you don't realize the difference. What happens here is that you don't tell SwiftUI, date formatter is a default value. You tell SwiftUI, every single time you create the view, create it with a brand new date formatter. So two things happen. First of all, it's wasteful because you recreate date formatter again and again and again and again. Second, if you changed anything about date formatter, you're not going to see that change once your view gets re-rendered. So if you ever had an issue where something changed and it doesn't show up in the app, maybe that's you accidentally made something that's supposed to be a state object, accidentally made it an observed object. And this is something that Apple talks about a lot, actually, in Data Essentials in SwiftUI. If any of that is new to you, if you still feel like you're confused about the difference, those differences are crucial in SwiftUI. State, binding, state object, observed object. If any of this is, if you don't feel like you really understand what's the difference and what to use when, and you get confused like, oh, what do I need to do here? Highly recommend watching that talk. Definitely still relevant 2 years later. Okay, moving to the third thing. Any questions before we move on? Sweet. So the next one is avoiding redundant view updates. So when we create a state and we think SwiftUI is so smart, usually it is not as smart as we hope that it will be, or as we want it to be. Usually what happens when we have a state with a bunch of properties, and here it's a state on purpose. So the regular state means a struct, right? Every single property in that struct, if it changes, and you can see that with the green square in the middle, SwiftUI thinks your entire thing changed. SwiftUI has no idea that only the bottom left green square is the property that changed. And so now SwiftUI needs to diff and compare and do everything you saw earlier on the entire body, on the entire view, on everybody that depends on that state. So this is, again, very wasteful. And so a bad thing you might see is you have some manager, or all these like bucket states, like blah blah provider, blah blah context, all these things. They would have the same behavior. On state object, the only difference here is that it's not for every property, it's for every property that you declare as published. But still, SwiftUI has no idea which of the published properties changed. It only knows that that object changed, that state object changed somehow. So a better way is to give your view the actual things that that view needs. And so if that's the cupcake view, and we know that the cupcake view doesn't need the entire manager with everything that's inside it. We know that the cupcake view only needs the cupcakes and the config, which is maybe, I don't know, today's menu or whatever. Just pass those things explicitly. It might feel sometimes like a little bit, doing a little bit of like pipeline work, or like kind of like annoyingly passing specific things, or it might look a little bit more messy, and it's very nice and clean that you have this one manager who just give everything. And that's true, all that is true, but if you care about performance, this is the way to do it. And there is a very good way to make sure that you avoid redundant view updates, and that's underscore print changes. This is not keep that, as you can see from the underscore, you should not use that in production, but when you debug your app, you can just throw that in the beginning of everybody you care about. And then what SwiftUI will do at runtime, you will get, every time that body is called, you will get a print statement in your console saying, this body was now called. Again, it doesn't mean it's rendered on screen like you saw earlier, but it was evaluated. So you spend the cost of building that body and building that view, and it will tell you why. So it will tell you body is now called for cupcake view because, I don't know, user config changed, or because this environment value changed. So then you can actually know why it happened, and then as soon as you see something that doesn't make sense, you open your 3 dots menu, and something on the other end of the screen is recreated. That's already very fishy, and you can start trying to figure out why that happens and how to avoid that. So that's about avoiding redundant view updates. The next one, split state into custom view types. And here we get a little bit more into taking advantage of how SwiftUI technically works. And so you might have this big view, and that big view has a bunch of stuff. Some let, some state object, some state. And then different things in your body would use different parts of your state. And you might ask yourself, oh, this is a very big body. How can I avoid calling this entire thing? Let's say only the red state is changed. I don't want this whole thing to change. I want just my red piece of the body to be evaluated. So when you have that, the type of the body is everything that's inside the body. And so this is another fictional example from, this is actually real print, but just a random code I wrote. But this is actually the type, and that's why we write some view, because nobody's going to figure that out when we type the code. But essentially, when SwiftUI compiles your code, it figures out everything inside the body and creates a type that contains everything you have in that body. That means that when we diff that body, we have to go through all of that stuff. We have to create all of these views, check the states for all of them, and do all of that work. So something some people do, they think, oh, I will split that into property, into computed vars, and then SwiftUI can pick and choose or do whatever optimizations. That does not help. That is exactly the same as what you just saw earlier. Because in the end, the Swift compiler will take all of that and as far as we know, the compiler might decide to optimize that and literally inline that code inside body. So this basically gives you absolutely nothing. I mean, it might make the code more readable, but it's not going to make it more performant. Another thing people do, they put pieces in view extensions. Same thing. You're not going to get anything from that. What you can do is you can declare new view types. You can take the parts of your body that are that use certain states, and then you can say, I'm going to split my body based on which part uses which piece of the state. And it might be counterintuitive because, you know, full view and bar view, for example, might be very, very related product-wise. And in your mind, naturally, it might feel like they should go together. But the fact that they need different states, that's a very good candidate for actually splitting them into two different view types. Once you do that, if you go back to, again, the comparison I showed earlier of how SwiftUI compares. So imagine what happens here. SwiftUI, let's say body changed, or whatever is the actual view of that body changes. SwiftUI now calls that body, and then it's going to create full view, bar view, and bis view. But it's only going to check those states. It's not going to call the bodies of those new views unless it's needed. And then, no, I just skipped one. How do I go back? There we go. And then the body of the new view is only that. And so this is way easier to diff, way simpler for SwiftUI to figure out, and way faster.
On the last slide, you dropped some on the types, or is it just like you're passing in the actual certain objects? That's what this is highlighting.
Wait, I'm sorry, where? This slide?
Yeah, this slide. Yeah.
So what's the question?
So some is dropped off the Java. Is that part of it, or is it just?
No, that's because, so those are actual new types. Yeah, I'm sorry, this is actually confusing. So this body belongs in some view, and it might be cupcake view, parent view, whatever you want to call it. I think I called it big view a few slides ago. And that's a struct that conforms to view. So those new views you essentially declare, and yeah, this is a little bit confusing because inside each of those structs, you have a body that returns some view, and then that body creates those pieces. Yeah, this slide is a little bit confusing. I'm just realizing now. So yeah, this is what you're going to end up with. Okay, and then I'm going to go now to the probably the most I don't know if sketchy is the right word, but or hacky or whatever you want to call it. But I do have oh yeah, spicy is what I used here. Spicy search and warning. So I do have a few disclaimers. Well, out the disclaimers. Here we go. Disclaimer. Number one, none of what I'm going to show is part of the official SwiftUI API. Have that in mind. Underscore functions should not be used in production. Any of this might change in the future. Yeah. And I am not a tax advisor, and this is not a tax advice. So now that we have all that, nobody's going to sue me, we can move on. So utilize POD or equality. So POD stands for plain old data. I don't know if the old in the way I wrote it is officially, but that's how I know it. And basically, SwiftUI splits your views into two kinds, POD and non-POD. And then based on that and a few other things I'm going to show, it's going to decide how to compare your views. So I don't know if anybody noticed, but in the slide I had showing that SwiftUI is comparing the state and the body, at the corner I had something like simplified. Now we're going to break down that simplified part. So there are three ways to compare views in SwiftUI. One is using memcompare, which is a very low-level C function that essentially compares the actual memory of the two structs. Because if you think about it, SwiftUI view is just a struct with data. As long as you didn't call body, this is just a simple struct with a few lets and vars and whatever it has inside. So memcompare is literally comparing the bits of the two structs and seeing if there's any difference. This is super fast, like you see with the host emoji. And then the second, a little bit slower. That one depends on how you implement it, but usually it's a little bit slow. I mean, it's probably always a little bit slower than memcompare, is equality if you implemented it. And then third and the slowest version is reflection. Unfortunately, many times, especially if we don't do it carefully or we don't write our SwiftUI code carefully, reflection might end up being the version that happens almost always, which is the slowest one. So before I'm going to talk about how to affect that, let's go over what POD even means. So like I said, there are two versions of using SwiftUI, POD and non-POD. POD basically means there is nothing complicated about this view. It's a bag of data. It's a bag of dependencies. And so on the left is just it's just an example of something that would be a POD view. We just have a very simple list of lets. And also, something I realize now I forgot to say, and it's also a misconception in SwiftUI, the fact that these are lets doesn't mean that this view will not be refreshed if they are changed. If these lets are provided from somewhere, from above, and wherever that value is coming from changed, this will still be recreated. You don't need to make this state, binding, observe, none of that. You can keep it simple, let. If you don't want to change that, let is what you want for either a structure or class. And then if it's a let, then you are helping SwiftUI making your view a POD, and we're going to see in a second why it matters. Non-POD view is when you have all these complicated stuff, like state, like binding, like environment, and a bunch of other stuff. It might be, it's not very easy to know ahead of time what SwiftUI is going to decide. And so thankfully, Apple gave us a function, which is _isPOD. You can call that on your type, on the type of your view, and SwiftUI will tell you, yes, this is a POD. No, this is not a POD. So when in doubt, just call this function and you will know. There we go. So in terms of what is used when, POD views always use memcompare unless they are wrapped in equatable view. This is going to get even more complicated, so I'm going to show the same thing in like 5 different ways. Hopefully, you will get at least one of those ways. Non-POD view always uses reflection, which is the slowest version, unless it's equatable. Okay? This is kind of like trying to do the TLDAR on anything. So reflection is basically when SwiftUI decides this view is just too complicated to compare the memory. I need to go, one by one on the properties, provide the state and whatever needs that view needs to actually decide if it's changed or not. And memcompare is literally taking the struct, seeing if the same bits or not. And so there's like a slight difference here, as you can see. POD, the only way to make it use equatable is to wrap it in equatable view. And non-POD, you just need to declare it equatable or implement equatable, basically. So I'm going to show it. This is basically showing exactly the same thing in a new way or in a different way, kind of like a decision-making tree. So is the view POD? If not, is it equatable? If no, it's reflection. If yes, double equals, assuming you implemented it. If it's not a POD, if it is a POD, I'm sorry, is it wrapped in equatable view? And is it equatable? Okay, double equals. Otherwise, I'm going to use memcompare for performance reasons. This is again showing exactly the same thing. The only thing that matters in this table is that you can see that with the POD view, reflection is never, which is amazing. It's great. That's what we want. Non-POD view, memcompare is never, which is not fun, and we don't want that. Very confusing. No idea why this works like that. But a way to kind of like try to understand the perspective of the SwiftUI team is equatable lets you avoid reflection. So if you're thinking, I don't know what about this whole POD situation, I just want to make sure I don't use reflection, you can implement your own equatable. Equatable view, which is a view you use to wrap your view with, lets you force using or double equals. If you say, I have something very important, I have to check in my double equal function, I have to use equatable, wrap it in equatable view. And then the big question is, okay, what we can do about this whole thing? Now that we learned about all of that, because sometimes we need state, we need state object, how we can use that. So there's this kind of hack that I figured out while working on the app. I work on it at Adobe, which is very heavy with images and I/O and stuff like that. You can split the dependencies from the state of your views. And so dependencies are the things that your view depend on, like simple lets, things that will usually go in a POD view. And state are things that will usually go in a non-POD view, like binding and environment and all those things. So let's imagine the following scenario. Let's imagine we have this expensive view, and it has a value, cool, simple let. But then we also have this item, state, not cool. Now our view is non-POD, and it's going to be using the slow reflection situation. What we can do with this view, I don't know if you notice here, but state is private. And you can always declare your state as private because you are the one providing the initializer. So nobody else needs to know that it even exists, right? So first of all, you can just always do that to have nicer autocomplete in Xcode. But also, the fact that it's private means you can actually split your view into two views, an external one or public one, and internal one. And then you, like I said earlier, you split the dependencies and the state. So the external one only has the dependencies, the things that your view actually depends on publicly. And the internal one is what is where you put all of your states, which is the things your view knows how to create. Nobody needs to know about that. Implementation detail, nobody cares. What happens here, and then in the public one, all you do is literally you just create the internal one. What this means is that whatever happens in the parent view, when expensive view needs to be diffed, valued, recreated, whatever, SwiftUI only needs to check this simple int value, and that's it. That's going to make diffing so much easier, faster, and quicker for SwiftUI. And you just made yourself a POD view that inside it has a non-POD, but nobody cares anymore because the external one is already going to pass the diffing as equal, and the internal one is not even going to be recreated. Slide, yes. The what? Oh, Flutter is doing the same thing? Oh, nice. Yes, he just made a comment that Flutter is actually using a similar pattern to optimize things. Yeah, this could be something that's maybe one day SwiftUI team will just automatically do for you to optimize, but today that's not the case, and you can get pretty nice benefits by doing that. A small anecdote, beware the closure, and I think I'm almost out of time, so yeah, I'll be quick. Beware the closure. If you pass a closure, SwiftUI doesn't know how to diff that because closures are very hard to diff. And so what Apple actually recommends, and you can actually see it in the Swift interface for things like VStack and I forget which other views, just open the closure. If it's a container view, that closure will just going to create the view. That view is just a bag of bits again. That's not going to be heavy to keep. Just open the closure, keep the actual value, the actual content in your container view. And that's going to make, again, now it could be a POD, now it can be a much easier comparison. And this is actually from a blog post by Rance. So if you're curious more about how closures affect view diffing in SwiftUI, check out this blog post. So in summary, keep view body simple. Own state or created state is state object. Past state is observed object. Avoid redundant view updates. Split your state into custom view types, and utilize POD or equality. All these are things that help you have great performance in your SwiftUI, but I think that great SwiftUI in general is actually split it into three sections. And we only talked about the third one. One is structure, which is the behavior. One is style, and one is performance. Structure is basically making sure the code is correct and that it's doing what you think it should be doing. Style is all the things you can bike shed on for forever. your code layout, where it goes. Most importantly is the last line here. Make sure your code is easy to delete, which in my opinion is the most important thing about any of the code design patterns. And then performance is what we talked today about making your code compile fast, run fast, and increase stability. So I've been creating this document for the last year plus, which tries to help with writing great SwiftUI. It's not a guide on how to do SwiftUI. For that, I think there are amazing resources, and actually, that document links to those resources. This is just specific tips, kind of the style you saw today about performance. So specific tips about structure, style, and also performance. A few things I didn't talk about regarding performance because we didn't have time. So if you're curious, check it out. Feel free to comment on it. It supports comments in the document. And I think that's it. Any questions? All right.